Beyond the last star, beyond the last galaxy, what really waits for us? Is there a cosmic wall, a giant sign that says, "End of universe, turn back now"? For centuries, humanity has stared up at the night sky, wondering what lies beyond our reach. The idea of an edge to everything feels natural, like the boundary of an ocean or the end of a map. But when it comes to the universe, that simple idea of an edge doesn't just fall apart, it completely melts away. We're going to dive deep into what science actually tells us about the universe's ultimate limits, and trust me, it's far stranger and more mind-bending than any simple wall. When we talk about the universe, it's easy to picture a giant bubble floating in some bigger nothingness, with a definite skin or a solid boundary. But here's the kicker: the universe, as far as we can tell, doesn't have a physical edge like that. There's no big grand barrier you could ever bump into, no place where space simply stops. This is one of the hardest concepts for our human brains to wrap around, because our everyday experience is filled with boundaries. Your room has walls, the Earth has an atmosphere that fades into space, but the universe itself, it just keeps going. Think about it this way: if you were to somehow travel in a straight line past every star, every galaxy, every cluster of galaxies, and you kept going and going, would you eventually hit a wall, or would you just find more space? Most scientists believe it would be the latter. They believe the universe is either infinite, meaning it literally goes on forever without end, or it's finite but unbounded. That finite but unbounded idea is where things get really weird and interesting. Imagine a tiny ant walking on the surface of a balloon. From the ant's perspective, the surface seems endless. It can walk in any direction for as long as it wants and never hit an edge. It just keeps finding more balloon. But we, looking from the outside, know the balloon is finite. It has a measurable surface area. The ant can't fall off the edge because there isn't one. Its universe, the balloon's surface, curves back on itself. Our universe might be like that. It could be finite in size, but because it's curved in ways we can't easily perceive from our three-dimensional vantage point, it doesn't have a boundary or an edge that you could ever reach. You could theoretically travel forever and just end up back where you started without ever hitting a wall. Pretty wild, right? It's like the universe is a giant cosmic loop, only infinitely bigger and more complex than a simple balloon. Now that's about the universe as a whole, but there's another kind of edge we talk about, and it's super important to understand. This is what we call the observable universe. This isn't a physical boundary of space itself, but rather a limit to what we can see. Think of it like this: if you're standing in a huge dark stadium and someone shines a flashlight, you can only see as far as the light reaches. Beyond that, the stadium still exists, but it's too dark for you to see it. The observable universe is simply the sphere of space around us, from which light has had enough time to reach Earth since the Big Bang. The Big Bang happened about 13.8 billion years ago, so the furthest light we can detect has been travelling for nearly 13.8 billion years. This creates a cosmic horizon, a sort of visual bubble around us. Everything within that bubble is our observable universe. But because the universe has also been expanding during those 13.8 billion years, the actual distance to the objects that emitted that light is much, much farther now, about 46.5 billion light years in every direction. It's like the light started its journey from one point, and that point has moved away from us as the light travelled. What's beyond this horizon? More universe. It's not empty space. It's not a void. It's just more galaxies, more stars, more cosmic structures, exactly like the ones we see in our own observable neighbourhood. The only reason we can't see them is that their light simply hasn't had enough time to get here yet. It's still on its way. So, if you were to magically teleport to the edge of our observable universe, you wouldn't find a wall. You'd just find yourself at the centre of a new observable universe with a whole new set of distant galaxies visible around you that we can't see from Earth. The universe doesn't have a centre, and every point is effectively the centre of its own observable universe. So, when we peer out to the very edges of our observable universe, what do we see? We don't see a sudden barrier, a cosmic brick wall, or a sign that says "space ends here." Instead, what we're seeing is more of the same, but with a critical difference. We're looking back in time. The light from the most distant objects we can detect started its journey almost 13.8 billion years ago. That means we're seeing those galaxies, those cosmic structures, not as they are today, but as they were billions of years ago when the universe was very young. It's like looking at a really old family photo album. You're not seeing your great-grandparents as they look right now, but as they looked decades ago. In the same way, the edge of our observable universe shows us the universe in its infancy. We see young, forming galaxies, hot clouds of gas, and even the faint afterglow of the Big Bang itself, the cosmic microwave background radiation. This ancient light is essentially the universe's baby picture, and it's spread out in every direction, appearing to us as a uniform glow. So, the edge is less a boundary and more a window into the past, showing us how our universe started to take shape. Beyond this observable horizon, where the light simply hasn't reached us yet, the possibilities open up to pure speculation. And that's where things get even more exciting for scientists. We can't see it, we can't measure it directly, yet, but we can theorize about it. One of the most popular ideas is that our universe isn't the only one. This is the concept of the multiverse. Imagine our universe is just one bubble in an endless ocean of bubbles. Each bubble is a universe, and they could all have different physical laws, different types of matter, and even different numbers of dimensions. Some might be expanding, some might be contracting, some might have already collapsed. It's a truly mind-boggling thought, and while it sounds like science fiction, many serious physicists are exploring different multiverse theories, from baby universes branching off our own to an infinite array of universes popping into existence from a chaotic quantum foam. Another idea is that our universe simply continues on infinitely, beyond our observable bubble, with more and more galaxies and structures just like ours, forever. There's no special reason for it to suddenly stop or change its fundamental nature just because we can't see past a certain point. These are not just wild guesses, these are questions that drive modern cosmology. Scientists are developing new mathematical theories and new experimental approaches, like looking for subtle clues in the cosmic microwave background to try and find evidence for these grander ideas. The quest to understand what lies beyond our current perceptions pushes the boundaries of human knowledge and sparks the imagination like nothing else. So, at the edge of the universe, you won't find a physical wall, a giant drop-off, or even a mysterious portal. What you'll find instead is the limit of our sight, a cosmic horizon that tells us not about the end of space, but about the beginning of time. It's a veil that hides potentially infinite expanses of space, perhaps even other universes, and conceals the deepest secrets of our universe's earliest moments. The journey to peek beyond this veil remains one of humanity's greatest scientific adventures. To keep exploring the universe with us, check out this video next.